Hi everyone, hope you get a bit of energy for this talk. I'm Arnaud Giuliani, Coin project lead and creator, co-founder of Codezilla and also a GD for Kotlin. Just to know a bit about of you, who is using Coin inside the room? Understanding if, okay, a few people. Who is using Compose? Lots of people. And who is using KMP? Not so much too. Then. Fine, then that's probably there will be perhaps something that they will learn in this talk. Then here we are talking about Coin dependency injection framework and how it really integrates in whole the entire Kotlin ecosystem. The project has been created in 2017. And then has been really rocking since a few, let's say 5 million downloads in 2020 per year. And those days we are reaching like more than 11, 20 or 12 million downloads per month. Then really the growth is great and we have lots of big applications that are using Coin and we are quite proud for that. And today the good thing is that also, in terms of announcement, we are ready to say that Coin 4.0 is ready, and then we'll jump for the new generation of Kotlin 2 APIs. That's cool. Then today I will talk about those new features and everything about that. To give you a bit of introduction about why Coin and how it has been created. The idea was really to simplifying the pain behind the eye for Kotlin developers, mainly Android developers first, and then also give you more power through Kotlin language. And for that, Coin has been thinking as a DSL. That means it's purely Kotlin keywords, okay, and it's a small container that hosted all your instance. And behind that, we have API that help you request all those instances for your application. Then, if we are taking a bit of code, let's take two classes that we want to inject, one repository, one presenter, and then with Coin, the idea of Coin was to have something that you can read and understand directly. And the good thing of that is that you can easily also write any kind of configuration just by reading any existing configuration. Then we are describing module with just a few, the module function like that, opening lambda, and then having keyword singular off to describe that those classes will be declared inside Coin. Then we are targeting the double semicolon character. We are using it to target the class constructor here. And also you can use lambda to have any kind of Kotlin expression behind that. Once you have described your instances, then you can start Coin, then you start the container to read what you have inside, and then it will read your modules and then load everything you have to read. Then you see that in a few lines it's super simple, and if you need to extract instance outside of this container because then the container can create instance for you, then we also have a few API that help you retrieve those dependencies. This is the minimal things about Coin. And Coin is a IOC container. Then it helps you make dependency injection through this container. And the idea was really ease of use and productivity. On Android, we need a bit more of magic for that. Why? Because let's take a few modules. We have a special one, then single off is a singleton. Factory off is a factory. That means each time you request this object, it will be created in your instance. And in the Android application, you need to, in your application entry point, you need to start Coin container. And then from that, inside any activity, because then you don't create activity directly by end, we are depending on a life cycle, then we need to retrieve our dependencies. And this is where finally Coin pull all the magic behind the Kotlin extensions. Because then just by this line, my presenter by Inject, we are unlocking Kotlin extensions that are retrieving your extensions regarding your activity. And then you are requesting Coin to have your instance. The big power of Coin has been unlocking the capacity of view model in 2017 and 18. And the good thing of that is that with Coin, you have a special keyword, view model, you start your application, and then in your activity, you have something called by view model that is a delegate to create your view model. Finally, the history behind that is that it has been a good idea because by view model has been also get back by the Google Android team to finally propose the by view models where they have default activities, default factories. Then by view model really get Coin on the scene to propose an easy way to create your view model in a few keywords. Finally, the framework pushed you to use constructor injection, to have function, to use everything in this DSL, and then have field injection and lazy delegate everywhere in your Android application where you need to inject that. This is the basic of using Coin, a module, and then just using by inject or by view model in your application, and then you're done. And then you have all your application wired with your DI. For those who are really that want to build with big applications and want really are caring about scaling, then this is the topic that you have in mind. Testability of your application, configuration safety, and scaling over your application size. And this is how I can detail you about that. When you are developing with Coin framework, and you compare the same application developing Dagger, then you are saving up to 75 to 80% of your compilation time, because we are squeezing completely all the generation that Dagger is doing for you, that is generating hundreds of files. Then you are getting more time for you at the compilation time. Then that's really precious, because for example, on a project that takes you 20 minutes to compile, then you are coming back to something like 5 minutes. That really is a game changer. In terms of performances, now really over the years, we are getting really benchmark and more Coin is based on the same API as Hilt for many of the Android entry point, like view model, like Compose. Hilt and Coin are using the same entry point. And inside the container of Coin, everything is cached and optimized in terms of index, and then requesting something is something around 0.005 millisecond to 0.01 millisecond. Then in terms of performances, apart if you are doing really real-time application, then it shouldn't be a problem. And then if we don't do compile time safety, we can offer you another way to work with your verification and then bright test. The thing is, Coin offer configuration safety with tools behind JUnit. That means that finally you are not blocked by compilation safety because you are activating in the way you want it. And those tools, you just use them as a JUnit, and then you can embed it in your CI easily. For that, you use a Gradle package called CoinTest, and then you have an API called Verify that helps you check your configuration. And you will see it's very, very easy to do. In Coin.40, then we are improving that to detect also all the dynamic behavior that you can do with Coin. Because with Coin, it's completely dynamic, then you can pass objects through your configuration, through your structure, and then also then you can build a dynamic structure with that. Then this is just a JUnit. We have our module, and then to verify it, you call it .verifyInit, and that's it. The good thing is that you also have Android Verify that is whitelisting some common type for Android, like context, like application. And then it's run on your configuration and make on the test on the unit all the configuration inspection for you to detect if you have missing configuration values. The good thing that we are also bringing for Coin 4.0 is that now in this tool, when you miss something, the tool is generating any definition that is missing and also generate hint to help you copy paste the code if you are missing some configuration in terms of dynamic behavior. Then you can use the tool. If you miss something either you miss something in your configuration, either we can help you and then copy paste the missed configuration here. There was another tool called check modules that was super hard to use, and it has been deprecated in 4.0, and I don't go back too much on that. If you are keen of compile time configuration safety, then you can go with a project called coin annotation, that is coin over annotation processing with KSP. The idea the same is really simplifying your life as a developer, also bringing annotation processing in a more simple way than you can find in other technology like Dagger or Hilt, for example. Because, for example, we just add single on a class, then we can detect all your constructor and all your bound types. You don't have to specify anything about that. For example, then we have our two classes, then we tag them just add single, and we have a class, my module here. We can tag it add module, and then says also add component scan to say, scan the package of my application, and then gather all the annotated classes around that. Also, if you don't want to scan for package, you can go in the old way and declare everything in module via function that you can annotate. Then you can really unlock the way of your expressivity with either annotated components directly with the annotation, or either really write things in your module with annotated functions. By default, compilation safety is not activated. You need a KSP argument for that. And the good thing of that is that finally, in terms of overhead, the KSP generation, code generation is super low, because it's just generating a few lines of configuration that you need. It's not generating hundreds of files of factory. Then we keep really the impact super low for that. The other things around that also is that the compilation safety can be unlocked or locked in the way you want. For example, if you are refactoring an application and you want some middle step and you want to go over this compilation safety for a while, then you can unlock yourself. The base of Coin and the story of this framework has been the DSL, and the DSL has been has not enough information regarding, for example, the annotation processing. Then there's new projects that are launched in the 4.0 to make it safer for the coming time. I would say if you want to care about performances, the main point for Coin is that Coin is reading configuration at startup. And this is where, well, big application with hundreds of modules, then this is where you have to think about strategy to let Coin really run and don't block your application. And for that, we have many ways to go in background for you and to don't block your application. Something that is experimental in 4.0 is that now Coin offer you Android X startup capacity out of the box, and you don't have to configure anything. You just use this package called Android X startup, and then we will be able to unload the something that is the configuration of your application that is taking long time off in the Android X startup. Then we have the regular start Coin, and then the new API we try to write here is OnCoin startup. That is a callback to the Android X startup, and then we will call on the different context, and it will optimize your Coin module loading. The good thing, and is quite promising, because then on a regular loading we can save up 25 to 45% of the time to gain. That's really interesting. The other point also is having the capacity to use Coin with the internal coroutine engine to load everything in the background and then have lazy module loading. For that, then let's take our small configuration here. We can use lazy module instead of module, and then those modules will be loaded in background, and then you will unlock your main thread about that. What you can do is then wait for Coin to load and then be called back, or even try to call Coin when all your job to load your configuration is started. The good thing of that is that you can mix. You can mix, and for example, you can have a rule like 2080 and have 20% of your application that is directly loaded at start and 80% of your application that is loaded in background. Because your first screen, for example, don't need all your application, and Coin is dynamically populating your configuration tree, then we don't need to know everything at start. And then this is the magic of Coin. You can load really the first piece of component that you really need at start. This quoting capacity is now stable in 4.0. We have a good feedback on that. And the good point is that with App Startup and Lazy Module, you can really benefit from really, really good performance startup. And don't have, if you have really big application, then you can be confident in having your startup process not blocked by Coin. Let's talk about Compose, because this is really not so new declarative UI toolkit, but really the new shiny toolkit that all the people in Android really love. It's about composable function and kind of unidirectional data flow, because we are producing new snapshot of states. I don't want to go in details, but then the good thing is that Coin helps you directly in the API of Compose for many use cases, and really out of the box. And the good thing of that is behind Compose, you have benefit from a real simple lifecycle. That means that a composable appear, and then you can attach things on that, and then when it disappears, then you can drop everything. Then your lifecycle becomes really super, super light, and you don't have to care about your view model, where it's attached, etc., etc. Then we can use view model, but you will see that we can use other kind of object for Compose application. How it goes? You will see that it's really, really, really convenient. My main advice is for you to use those injection API inside your parameter value. Why? Because then you are not tied completely to Coin API, and then if you want to replace your instance with something that you want, for example in a test, then you can bypass Coin directly. If you do that in a body, you won't be able to do that. Then first function to show you is something called Coin Inject, where you can take any kind of object and then we inject that in your composable, and it will be tied to your composable lifecycle. The good thing of that, then, we are following the Compose cache, and this is the lifecycle behind Compose, and then you benefit from all of that. For view model, then you have Coin view model, and Coin view model is built on the same kind of API as Hill view model for that. Then we are tied to the same lifecycle, tied to the same API, injection of safe state handle and parameters and so on. Then you use Coin view model, and then you are injecting a view model. Then good thing is that you can really inject two kind of object. State holder, like minimal, really small objects that are kind of local to your logic. And if you have big global business rule, then you can have view model. Something that really you inject at the root of your composable view, and then you can really pass that view model around. And then state holder, you can use Coin Inject and declare it as a factory, and view model, you can use Coin view model and use the keyword view model for that. Now that you see how we can inject things, you need to start Coin inside a Compose context, in Compose application, and there's a few tricks that you need to know beside of a regular Android application. Like let's have this composable my app that is kind of our root node for our Compose application. If you don't do anything, then all the Coin Compose API will have to fall back to a default context. It doesn't really know where you want to go. You don't have set up any kind of context, then we have to go somewhere. You have two or three way to start with your context. Coin context, you declare, we say that we attach Coin in Compose to the current context. Coin Android context, we can do that to the last Android context, and then it's suitable to use when you are using tests, for example. And Coin application, you are starting a new context, you are starting a new Coin application from there. And the good thing is that now the Coin application can really handle the way that it can be restarted by an activity, or it handle completely the life cycle of the compose element. The thing that is interesting is that with Coin application, you can custom a preview, a compose preview. That means that if you want to preview something that is using a view model, usually you need to start your application. And instead of starting all your application, what you can do is really starting a small context, and then you can do a special preview compose application with Coin application function that give you the possibility to specify the way you want to do that. Last thing that is really interesting is that for Coin has the capacity to be completely isolated in memory. That means that by default, you are using Coin in memory, in the default memory, and it's available everywhere. But if you are making some SDK, then you can completely isolate Coin in the way you want, and then you can benefit from isolated memory for that. To start isolated context with Coin and compose, you use Coin isolated context, and isolated context is the variable of your isolated Coin context. You can find more in details in documentation for that, but that means that behind all the composable you are writing are completely isolated in memory. Like you can give this in your SDK to your customers, and then those screens are completely isolated and are not mixed with the memory of the host application. Then that's quite interesting if you are making SDK and you want to bring UI to your SDK and to your customer, then you can completely isolate yourself. Good thing of that is all those frameworks that try to help you on compose, kind of like circuit and decompose, they are compatible with factory. Then you can wire factory directly for Coin. And there is many other topic that we might really, that might be interesting for you, like compose navigation, scopes. You can also dynamically load new modules depending on your composable, for example. Then if you have an application that wants to load dynamically part of the application, you can do that. And of course, I advise that you look at baseline profile, where Ben Weiss from Google is advocating a lot for those tools. It can really save up lots of performance at runtime for compose. And all of this is multi-platform. We will comment that just later. About Kotlin multi-platform, is it just about sharing code? Finally, for Coin, what you will represent is that Coin will help you share module and share code between Android, between iOS, between desktop application. And you will see we just use expect actual mechanism from Kotlin multi-platform to help you declare native module in each case. Then if you are using pure Kotlin multi-platform API, you can use them directly in your Coin module definition. It's pure Kotlin multi-platform, then you don't have to worry about native side. But if you have a platform-specific module, usually you have that. For example, if you have embedded driver for SQLite, for example, or other kind of embedded database, you have to specify for each platform the module you want and then the kind of object you have to declare. Then, for example, here it's SQLite driver. It's out of People in Space application from John O'Reilly. You can find the project online easily. But then we have to define two drivers, the iOS one and the JVM one. And for each one, you have an actual of the platform, and then you can define your platform and then define your components for each one. Once you have configured your native stuff, you have configured multi-platform modules, then all your code is running. What you can do is that you can also have a special starting point for iOS, because then in Kotlin multi-platform, all the translation of your Kotlin classes is not directly 1:1. That means that you will see that we can't use directly start coin in iOS. We need to wrap a bit the function for you. What you need to do is, usually the most convenient is having in your multi-platform project a common start point called, for example, init coin, and you start coin from there. And in your iOS project, you can call directly the static function coinkt.do init coin, and you see that it's really deduced from your Kotlin class, and then we are retrieving your functions like that. Then having this kind of naming ensure you that you will find back your entry point for iOS. And one of the main problems between Kotlin multi-platform and native target like iOS is that we don't have all the magic of Kotlin extensions on Swift. And today we have some good translation between Kotlin and Swift, but this is not enough to bring really the magic of coin on the full platform of Swift. For that, I can share with you a bit of injection pattern, and this is something that has been gathered with all some Kotlin multi-platform experts that are sharing projects around online. The first one, and for example, and this is the most, I would say, straightforward way to try to share something outside of Kotlin multi-platform, will be to have an object class to help you export that object to the boundaries of your application. And like we have something called Kotlin dependencies, and then we want to expose our presenter instance. What we will have is having a function that asks coin to expose this entity to Swift. We are using a special interface here called coin component. This interface unlocks extensions for coin, and then you can use getCoin here or other kind of operator. But coin components let you unlock the coin capacity in any space of your application that don't have already extensions for that. Then outside of main Android application, for example. In your Swift code, then you will call directly the static function, Kotlin dependencies.share.getPresenter. Kind of straightforward, but not super convenient, because then you have to declare all your exported components between them. The other point that we would like to do is offer a way to bridge a class that is in between world, like that is in Kotlin multi-platform, used in Android, but also can be usable in iOS. And this is, for example, the case for this repository. We use coin component because then the problem is that on Swift, you won't directly call coin to inject that. We will ask the container to inject by field your component, and you will see why. The thing is then, what we want to do with KMM repository, in Android, then we can inject by constructor, that's fine. But on iOS, for example, if I have a iOS Swift class, then what I will do is I will create this instance like that, and then the instance will retrieve directly the instance by itself, thanks to the coin component mechanism. You see that it's not super easy, and on view model, sharing view model is not a peaceful travel. And you have a few proposals that are KMM view models and Moco MVVM. Coin don't provide directly all those bindings, because you have to bind lifecycle on both platforms. And this is not directly the work for Coin for now. And for example, we are using KMM view model. You have a class view model that is extending KMM view model. We use the coin component aspect to make field injection. And the good thing is that you just declare in view model. In Android, you inject by view model. Okay, fine. And on Swift, you need a bit more of stuff. You need to write these extensions to declare your extensions of KMM view model. And in your view, you can inject your view model like that with the @state view model annotation, and then instantiating view model shared like that. Not super straightforward, but there's a good solution for that. And then you have a KMM view model is really something that is regularly used in KMP platform. Then you see finally in multi-platform, things are not completely directly translated for you in between KMP world and iOS world. This is why we need to use wrapper and bridge aspect. You see there is still space to improve Swift interoperability, and of course Kotlin language will evolve in that way and help us bringing more capacity to work with that. Also, on the coin aspect, there's more space to allow you to bring those view models out of the box usable, and you don't have to to think about that. Still in progress. But Compose multi-platform is ready, and all the Compose API is fully multi-platform. That means you can write a Compose application in your common space, in your Kotlin common space. And the view model also is ready for that. It has been ready for the Kotlin 2 announced this year at KotlinConf in April. And then now in Compose, you have a Compose application. You can use completely all the view model API like you are doing Android. This is big work from JetBrains and Google about that, because then this is composed in 1.6.10 early this year, and they bind on each platform. They bind both lifecycle in Android and iOS to bring compatible API for you. You don't have to care about the lifecycle at the end. Jan Lake from Google, this is one of his tweets, talking about Lifecycle 2.8, and this is really the base where they begin to open the Google API as multi-platform API. Marcello also, that is helping me on Coin, also shared many information about the multi-platform API at Google, and they made a video about that, how they made their choice, they made some choice, and what object has been ported directly in the KMP world. And finally, when you are doing Compose multi-platform project, etc., then you depend directly on org.jetbrains.compose library and not anymore on org.androidx, etc., etc. The good thing of that is that finally the API seems the same. Sorry, it's a bit verbose, but at the end, when you are playing with a Compose application like here in Fleet, you can use naturally coin view model inside your application, and you are in your Compose multi-platform side. Then that's really looping the loop. Finally, all the Compose stack is ready for the multi-platform side, and then it is running directly on iOS. It's really smooth. All of this then run on iOS, of course, and desktop and WASM. And this is target that also cover coin and get you dependency injection for those targets. I don't know if there is a few people that are making backend here. No developer that accidentally made some backend. Ktor, this is the backend technology in Kotlin developed by JetBrains, and the Coin, that is an agnostic technology, has been ported for Ktor. And the same, it's super simple to start and to use Coin inside Ktor. Usually you have an entry point, you install Coin inside, and then you begin to inject your components. And then you can declare routing, and then you're done, and then you have Ktor and you have Coin running directly. For information, we at Cozilla, we are working a lot on Google Cloud Run, and we have clusters of Ktor application, Ktor plus Coin that are running really in parallel. We are using our own tool, then that's good sale. The same, you can run isolated, you can run on default configuration. There is scope request, then if you want to create new stuff on each request, and testing has been made completely integrated in the Ktor test. That means that when you use test application, then you are running Ktor, you are running your coin context. In terms of orientation for Ktor, then JetBrains really communicate about their intention to really open the integration for DI technologies such as Coin, not only Coin, but such as Coin. And then they try to open the work about having this kind of technology more and more integrated. In terms of development, it posed some question about Kotlin 2 context parameter. This is a new way to bring you those context parameters, and this could replace those lazy injection. And perhaps we could use that also for compose data, where we see. And Ktor also has plugin registry where they already made coin available for Ktor developer. That's cool. You've seen a bunch of stuff around coin. Then here's an extract of the main committers, and really, I really like to thank them each time I have a conference talk, and then coin is there also thanks to them, because then this is feedbacks of lots of people, lots of companies, then it can only become better because of all of those people. Then if you want to go on documentation, there is website insidecoin.io, on Twitter, on Kotlin Slackline, there is a channel called Coin, and there is also, you can find it easily on Twitter. We need your feedback. This is super important to make everything evolve in a good way. If you want to test coin, there is tutorials for Android, view model, annotation, etc., multi-platform. Then you can really jump in and then start using it. Now in Android is the Google application that is demonstrating the main patterns about compose, about blueprints, about the best practice on Android. We have migrated it for coin, and then you have one version here. That's cool. Then you can find it on GitHub. We also open some webinars to help people that want to migrate from ILT or other kind of technology to coin and KMP, and then we try to talk about those strategies to help you migrate from that. In terms of versioning, it's important because then coin is depending on many different ecosystems like Compose, Android, the multi-platform side. Then coin offer community cycle of 6 months there. That means for 6 months, you are quite sure that this version, the main version, is maintaining. And the current version, we have coin 3.5 that is ending this week, because then we release coin 4.0, and the new stable version is 4.0. Many work around coin 4.0. You need Kotlin 2.0.20 because then we are using the new UUID, the new Kotlin multi-platform UUID functions. All the internals has been revamped, then, and many features are now stable. Then that's kind. All about Compose has been really stabilized, and then now is getting more and more work on all the view model as you have been seen, and that's really cool. And Coin help you develop your Compose multi-platform application. And also a project called CoinFu to have this functional DSL experimentation. And then annotation, it's a bit async because Coin annotation 1.4 that is soon released is still on KSP 1.9, then we are one version behind, but then we will have soon Coin Annotation 0.0 that will use KSP2, and it's offering more stable compilation safety and all the kind of features that you can follow up. More and more, we will open more experimental integrations with other projects and all the kind of technology like Kotlin RPC, but also like Voyager and Circuit, trying to talk with other project initiative to offer space to have official integration and help them maintain that. And also open proposal for the community to help propose integrations like it can be. It's not yet in the official project, but then you can propose new ideas for Coin. Just to finish, a bit of advertisement. At Codezilla, we are part of the Kotlin Foundation, and then we help promote and make Kotlin as a better language. Then that's cool. Cool to be with all those people to promote Kotlin multi-platform. Then Codezilla is the company that is behind Coin and then helping in terms of many support. Sorry. Then you can talk to us at the sponsor room venue if you want more information. And we are working on new dev tool for Kotlin about debugging and making traceability, about coin application and compose application, and then we help audit your component structure, help you understand scope, lifecycle, memory allocation, because with coin we can understand how you allocate, when you try to allocate things, really trace about scopes, dynamic behavior, etc., then understanding where you have problem with threads, performances, and bottlenecks, and everything is KMP ready. That means that really the code that you are sharing, you can really understand how it's behaving, and you have really more traceability on that. We are working also on a new IDE plugin for Coin, and then it's coming soon. All the information are available on Codezilla.io, and thank you for your attention.